Hello guys, this will be a small video on how to make the new reduced size NFC tag reader. Now before we start, the thanks goes to Andrea Dono for his project. I'll leave a link in the description to his GitHub account and you can have a look of its cases, codes and everything. So thank you. Now what we need from this project, this was the old one, the normal one, and this is the smaller reduced version. Now I'll show you how I made this. Let's remove it and we'll have a look. Now I have this little tape in here because there is an LED in here. There's a small LED in here and you can see through the case. It's not very nice. If you don't want to remove the LED, just cover it. Now basically what we need for this project is the mini D1 or ESP8266. We need the PN532, which is this red board. This is an RFID board. We need a WS8212 LED, which is this LED here. We need a flat buzzer, which is this guy here. And we also need this USB board. This is a USB-C board. Now the PN532 has a switch in here which is marked as S1. Okay, we are using the IC2 protocol. You see, IC2 protocol, pin 1 is on, which is up, pin 2 is 0, which is down. So this is important, otherwise it's not going to work and you're not going to know why. So basically what we have here, first of all, you need to get power to this. Let me zoom out a little bit. We need to get power to this USB connector in here. Why? Because if you notice the case, it has the opening on the side and there's no way you get the mini D1 unless you make another hole. It's not going to work. So the best solution is, let me unclip it, get something like this, which is a USB-C board. These are really cheap on AliExpress. You get a little cable with a 4-pin connector, male on one side, female on the other one. And if you look at the board, this has 4 pins. One is marked V. This is the VIN pin or the 5 volts pin. D minus, D plus and G. On the mini D1 I've got the VCC pin, the 5 volt pin from this capacitor here. You see there is a capacitor in here which is ground on one side. This is ground, this is 5 volts. So this is my 5 volts. Then the ground pin, I just took it from the casing on one of these anchor pins in here. Now for the D plus and D minus pin, now according to the schematics, which it should be on the screen now, the D minus pin, so this is the USB controller, okay, so the D minus pin is 1 2 3 4 1 2 3 4 5, the fifth pin, and the D plus pin is the fourth pin. So D minus, fifth, D plus, fourth. Anyway, we should look at the schematic and it's easy to identify. So with these four cables, the fourth and the fifth pin from this IC, power from this capacitor, and ground from this anchor pin, we are giving power, not just power, but also data to this. So you can, if you want to flash it, you can flash it through this connector. Now, if you're not interested in the data pins, you can just ignore these two pins and just give power through these pins. But if you need to flash the board, you need to take it out. Now, once you've done this, you establish the power connector through this USB. Now this USB, let me zoom out a little bit, would go in here, you see? Okay. Now you want to make sure these cables between the Mini D1 and the PN532 are not very long. That's because we're gonna make a sandwich between the two of them. You don't want to lock a lot of cable running around. Now, how do you connect this? If you look at the PN532 board, you've got a pair of headers in here and a pair of header holes in here. Now first we're going to need these ones. Now you've got ground in here. This goes to the ground pin on the Mini D1. Then you've got VCC, and this is power, and this comes from the VSUS or the 5 volts on the Mini D1. Now then we have SDA. SDA would connect to pin number 2 on a Mini D1, and we have the last pin SCL. SCL pin, which is the clock pin, will connect to pin number 1 D1 on a Mini D1. So SCL D1, SDA D2, ground to ground, and VCC to 5 volts. Now with all these 4 pins in here, you've got the tag reader working. Now if you want to add the LED and the buzzer, you need to add a few more pins. Now the buzzer has 2 connections. One, let me zoom in a little bit. One which is ground, and the other one will connect to pin D7 on the Mini D1 in here. Now the buzzer, if we have a look in here, you can see if we look at it, is marked with a plus, and the opposite pin is the ground pin. Now if we have a look at the LED, which is this one, now this LED is a WS2812. Now this LED is an RGB LED, and is using 3 connections in here. We have 3 connections. We have one which is marked plus. This is 5 volts. This comes from the 5 volts on the Mini D1. So I took the power from the PN532 instead of Mini D1. Is the same, because this pin and this pin are the same pin. This is a track that go from here to here, and this pin comes from the mini D1, so there's no point adding a lot of cable to the mini D1. Now on the other side you have another VCC pin. You can take the 5 volts from here. Now the 5 volts comes from the RFID board from the VCC pin. The ground, again, next to the VCC pin you've got a pink ball ground. Now take the ground from here to the LED pin marked minus or ground. You see GND or minus. And the middle pin is marked DIN, data input pin. Now this pin goes to the mini D1 to pin number 8. Now for the buzzer is a lot simpler. We have the ground pin, which again we've taken it from the PN532 from the ground pin, and we have the data pin which goes to the mini D1 to pin number 7. Now once you've done all this, you can just zoom out a little bit. You can just sandwich the board like this. If you want to use a little bit of tape, you can use a little bit of tape. Now we connect this cable. Now if you don't want to use a connector for this board, you can just solder the cables. I use a connector, so in case I want to take the board out, I can just remove the board, because I will glue this in place. Now this goes in here, and this will only go one way. If you see, it's not going to fit like this, it's only going to fit like this. So this cable goes under the board, and this will be glued in here. Now this goes like this. We get the buzzer in here as well, and we got the LED in here. Once you've got all this beautiful sandwich, just close it, and this is it. Thank you for watching. Now let's have a look at the software part of this video in a minute. Okay, so let's have a look now at the software part. We'll connect the ESP8266 to the computer using a USB cable. Then you go to ESP Home. If you don't have created already the project, you add a new device, you give it a name. You can skip this test. Depends on the board you're using. In our case is 8266, and you will create, we skip this, it doesn't matter actually, because we are gonna edit, delete everything in here and just use the codes that we have in here. I'm gonna leave the code in the description. Now this is the code. You copy and paste this code into the project you just created. Once you do this, connect the board to the computer using a USB cable. Then you click on install. It's gonna ask you if you wanna connect wirelessly. If it's a device that you've been using and you want just to upgrade, and it's already connected to the network, you can choose wirelessly. If you have the device connected to the computer where you're actually working now, you select the second option. You can also flash it, connecting the device to the Home Assistant server USB, or manually you can just create the bin file and then just flash it using any other app. Now we're going to explore these two options. We're going to try first the first option, this one, plug into this computer. In order for this to work, you need to be on a HTTPS connection and a secure connection. Let's try now on a non-secure connection using the IP address. So if I go again in here and then install, you see it doesn't detect the device, the USB device. Now if you don't have a HTTPS connection, it's not gonna detect it. Now if you don't have an HTTPS, a secure connection or a domain, don't worry, just connect the board to any USB on your Home Assistant server directly, and then you go to the second option, plug into the computer running the ESP Home dashboard. Now it's going to ask you which serial port. It doesn't matter which one you choose. If you choose the wrong one, it's not going to work. So let's try this one, see if it actually does anything. It first has to compile the firmware and then try to flash it. Now if you choose the wrong USB, it's just going to give you an error. Now it doesn't matter, we close it and we install it again. This time we choose the second USB. It's creating the bin file again. Now you see it's detecting the board, okay, and it's flashing the board, and that's it. You've got the board flashed. Now this is connecting it directly to the Home Assistant, either if you don't have a secure HTTPS connection or simply because you want to do so. Otherwise you can just connect it. Let me unplug it from the server and connect it to this computer. Okay, now it's connected to this computer. Let's try now. We are now on a HTTPS connection. Let's see if we can flash it from here. This time we're going to say into this computer. You see now it detects the COM port and it's going to try to flash it. Now it's a lot faster if you plug it directly into the server, but if you don't have access to the server, you can do this. You see, it takes a lot longer than it was the first time when it was connected directly into the Home Assistant server. Let's see how long it takes. Okay, it's now flashing. And this is it. We now have the board flashed. We have the hardware already installed, so we should be good to go. Now thank you for watching. If you like this video, please like and subscribe. I'm gonna be doing a second version of the hardware part of this video in a couple of days for more advanced users, where I'm gonna remove the USB-C connector and I'm gonna be removing as well the I2C connector from the ESP board, and we're gonna see what's happening just to make the board a little slimmer. So I'll see you in the next video. Thank you and bye bye.